Hey everyone, welcome back to Maths Nation. Today we'll be going through the 2024 June Paper 2 Calculator Higher Tier paper. We'll be going through each and every question step by step to make sure we get the full marks. Let's get into it. Question 1 says ABC is a right angled triangle. Work out the length of CB, give your answer to three significant figures. To answer this question, we need to use Pythagoras' theorem. So, Pythagoras' theorem says that a squared plus b squared is equal to c squared, where c is the hypotenuse. So if I label my triangle, I'll call this side A, side B, and side C. A's are unknown, so we'll leave it as A. B is 10, so 10 squared, and that's equal to 19 squared. If I solve that, that gives me 100 is equal to 361. Rearranging the equation gives me a squared is equal to 361 minus 100. A squared is equal to 261. If I square root both sides, I have a is equal to the square root of 261. And that is equal to 16.155. Now, the question has asked me to give my answer to three significant figures, so that will be 16.2 centimeters. Question 2a is asking us to write 90 as a product of its prime factors. So we're going to use our tree diagram. 90 can be broken down into 2 multiplied by 45. Now 2 is a prime number, so we can't go any further there. 45 can be written down as 9 multiplied by 5. And 5 is also a prime number, so we're going to stop there. And then 9 can be broken down further into 3 multiplied by 3. And 3 is also a prime number. And so our final answer can be written as 90 is equal to 2 multiplied by 3 multiplied by 3 multiplied by 5. 2b says that a is equal to 2 squared times 3 and b is equal to 2 times 3 squared. Write down the lowest common multiple of a and b. Let's figure out what a and b are first. So 2 squared is equal to 4 times 3, that gives us 12. And 2 multiplied by 3 squared, which is 9, is equal to 18. So we need to figure out the lowest number that both 12 and 18 go into. So we'll use our little column method. Both 12 and 18 are divisible by 2. That leaves us with 6 and 9. Both 6 and 9 are divisible by 3. So that gives us 2 and 3. 2 is divisible by 2. So that gives us 1. And then 3 is divisible by 3. So we're left with 1 and 1. And so these are what we need to multiply together to figure out what the lowest common multiple will be. So that's 2 multiplied by 2, multiplied by 3, multiplied by 3. That's 4 times 9, which is 36. So the lowest common multiple is 36. Question 3. The number of hours H that some machines take to make 5,000 bottles is given by H is equal to 72 over N, where N is the number of machines. On Monday, 6 machines made 5,000 bottles. On Tuesday, 9 machines made 5,000 bottles. The machines took more time to make bottles on Monday than on Tuesday. How much more time? Well, let's work out what H is for each day. So H on Monday is equal to 72 over N, N being the number of machines, 6. So the number of hours was 12. The number of hours on Tuesday is 72 over N. N now is 9, and that's equal to 8. And so the difference between H Monday and H Tuesday is 12 hours minus the 8 hours, and so it took an extra 4 hours. Question 4 says that there are only red discs, blue discs, and yellow discs in a bag. There are 24 yellow discs in the bag. Mel is going to take at random a disc from the bag. The probability that the disc will be yellow is 0.16. The ratio between the number of red discs and the number of blue discs is 5 to 4. work out the number of red discs in the bag. Well, the first thing that we need to do is we need to work out the total number of discs. And we can do this by looking at the number of yellow discs we've got and the probability that we'll get a yellow disc. Well, the probability that we'll get a yellow disc is 0.16. And that is the number of yellow discs that we have, which is 24, over the total number of discs. We'll just call it total. So if we rearrange to make the total the subject, we have total is equal to 24 over 0.16, and that gives us a total of 150 discs. We know that 24 of them are yellow, and so if we say 150 minus the 24 yellow discs, that gives us 126 red and blue discs. They've told us in the question that the ratio of red discs to blue discs is 5:4, and the total is 9. And so if we say 126 red and blue discs multiplied by 5/9 to get the ratio of red discs, that will give us 70 discs. And so we have 70 red discs. Question 5a says, complete the table of values for y equals x squared minus x. So all we're going to do is we're going to plug in our x values into the equation to get the value of y. So when x equals minus 1, we have y is equal to minus 1 squared minus minus 1. That's equal to 1 plus 1, which is equal to 2. When x equals 1, we have y is equal to 1 squared minus 1, which is equal to 1 minus 1, which is equal to 0. And finally, when x equals 3, we have y is equal to 3 squared minus 3, y is equal to 9 minus 3, which is equal to 6. Part B says, on the grid, draw the graph y equals x squared minus x for values of x from minus 2 to 3. So all we need to do is plot our graph. So we have x is equal to minus 2 and y equals 6. So our first point is there. X equals minus 1 and y equals 2. Then x and y are 0, 0. X equals 1, y equals 0. X equals 2, y equals 2. And x equals 3 and y equals 6. We just have to join the dots up now. So it should look something like this. Part C is asking us to use our graph to find estimates for the solutions of the equation x squared minus x is equal to 4. Well, we've drawn the equation x squared minus x, and now we know that it's equal to 4. So our y value is 4. So what we're going to do is we're going to draw a straight line where y equals 4. And then we're going to figure out what our x values are. So if we go down, it's roughly there and roughly there. So our answer is going to be minus 1.5 and 2.5. Question 6 is all about ratios, fractions, and percentages. Andy, Luke, and Tina share some sweets in the ratio 1 to 6 to 14. Tina gives 3/7 of her sweets to Andy. Tina then gives 12.5% of the rest of her sweets to Luke. Tina says, now all three of us have the same number of sweets. Is Tina correct? You must show how you got your answer. Well, as we're dealing with ratios, the total number is going to be 1 plus 6 plus 14, and that gives us 21. So we know that Andy has 1/21 sweets, Luke has 6/21 sweets, and Tina has 14/21 sweets. Now, we know that Tina gives Andy 3/7 of her sweets. And so 14/21 multiplied by the 3/7 she gives, and that is equal to 2/7 sweets. So Andy has his original 1/21 sweets plus the 2/7 sweets he's just received from Tina, and that gives him a total of 7/21 sweets. Tina's lost the 2/7, and so her remaining is 14/21 minus 2/7, and that's 8/21 remaining. She then gives 12.5% to Luke. So 8/21 multiplied by 12.5%, and that gives 1/21. So she gives Luke 1/21 of the sweets. So Luke now has his original 6/21 sweets plus the 1/21 sweets he's just received, and so he now has 7/21 sweets. So now Tina had the 8/21 sweets. She's just given Luke 1/21 sweets, and so she is left with 7/21 sweets. And as we can see, they all have the same number of sweets. So yes, Tina is correct. Question 7 says ABCD is a quadrilateral. All angles are measured in degrees. Show that ABCD is a trapezium. So to show that this is a trapezium, we need to show that both angles 4x minus 5 and 2x plus 5 on this line equal to 180, or that these two angles 4x plus 8 plus 3x minus 3 equal to 180. Hence, by showing that those two angles are supplementary and therefore the shape is a trapezium. So if we say 4x plus 15 plus the 2x plus the 15 is equal to 180, we collect the like terms. 4x plus 2x is 6x, 15 plus 15 is 30, is equal to 180. We take the 30 to the other side, we have 6x is equal to 180 minus 30, 6x is equal to 150, and if we divide both sides by 6, we get x as 25 degrees. Now we're going to test that. So 4 multiplied by the 25 degrees plus 115 is equal to 100 plus 15, which is equal to 115. So this angle here is 115 degrees. And if we plug it into the other angle, we have 2 multiplied by 25 plus 15. That's 50 plus 15, and that's equal to 65. So this angle here is equal to 65. And if we add both angles together, it should equal 180. And therefore, this is a trapezium. Question 8 says, a playground is in the shape of a right-angled triangle. Dan makes a scale drawing of the playground. He uses a scale of 1 centimeter to represent 5 meters. The area of the playground on the scale drawing is 28 centimeters squared. The real length of QR is 40 meters. Work out the real length of PQ. So let's label this diagram with what we have. We know that QR is 40 meters, and we are asked to work out PQ. So we'll call that X. The area of the playground is 28 centimeters squared. So let's convert it so that we can figure out what the real surface area of the playground is. Now we know that 1 centimeter is 5 meters. And so 1 centimeters squared, we're going to square both sides. We're going to have 25 meters squared. Now we are told that the scale drawing is 28 centimeters squared. So we need to multiply both sides by 28. And 25 multiplied by 28 gives us 700 meters squared. So we know that the area of the real playground is 700 meters squared. Now we know that the area of a right angle triangle is half base times height. Well, we know that the area is 700 meters squared. half base we'll call x because we don't know that, and our height is 40 meters. So that's 700 is equal to 40 over 2 multiplied by x. That's 700 is equal to 20x. And so x is equal to 700 over 20. So x is equal to 35 meters. And that is the length of PQ. 9a says a number n is rounded to two significant figures. The result is 7.3. Write down the least possible value of n. So what we do is whichever number we have, in our case 7.3, we go down by 5 on the next decimal place. And so if we do that, that's 7.25. Part B says, Layla says the value of n cannot be greater than 7.349 because 7.350 would round up to 7.4. Is Layla correct? You must give a reason for your answer. Well, no, Layla is not correct because there are still numbers that are greater than 7.349 but less than 7.35. For example, 7.3491 is still less than 7.35. And so she is wrong. Question 10 is about trigonometry. The diagram shows two right-angled triangles. All lengths are measured in centimeters. Given that sine A is equal to tan B, work out the value of x. So we're going to be using our SOHCAHTOA rules. So the triangle on the left-hand side is clearly a sine function, and we have this length here, which is opposite, and this length here, which is the hypotenuse. And so sine A is equal to 7 minus 2x over 8. For this triangle here, we have the opposite and we have the adjacent. And so tan B is equal to 1 plus x over 4. Now, the question says that sine A is equal to tan B, so we can equate these two functions. 7 minus 2x over 8 is equal to 1 plus x over 4. And if you cross multiply, take the 4 to this side, that becomes 4 multiplied by 7 minus 2x, and 8 multiplied by 1 plus x. We expand and simplify. 4 times 7 is 28. Minus 4 times minus 2x equals minus 8x. And on this side we have 8 times 1 is 8. And 8 times x is 8x. If we collect the like terms, we'll have 28 minus 8 is equal to 8x plus 8x. 28 minus 8 is 20, is equal to 16x. And so x is equal to 20 over 16. And if we simplify that, that's 5 over 4, which is 1.25. Question 11 says that the frequency table gives information about the weights of 60 parcels. Complete the cumulative frequency table. Whenever we're dealing with cumulative frequency, we always add the previous frequencies together. And so for 0 to 2 is just 7. But from 0 to 4 is 0 to 2 plus the 2 to 4. So that's 7 plus the 21, and that gives us 28. And if we do this for all the rest of them, that will be 28 plus 15, which is 43. Then 43 plus 11, that gives us 54. And finally 54 plus 6, that gives us 60. Part B says, on the grid opposite, draw a cumulative frequency graph for your table. Well, in order to draw this graph, we need to get our x and y coordinates for each point. The x coordinate for a cumulative frequency graph is always the maximum of the inequalities shown here. And so, for example, the first point is going to be 2, 7. Second one's going to be 4, 28, and so on and so forth. 6, 43, 8, 54, and 10, 60. All we need to do now is plot these points. So 2, 7 is going to be here. 4, 28 is going to be here. 6, 43 is there. 8, 54, and then 10 and 60. And if we join these dots up, we should have something that looks like this. Part C says, use your graph to find an estimate for the interquartile range. Well, in order to work out the interquartile range, that's just the upper quartile minus the lower quartile. So the upper quartile is this 3/4 multiplied by our total frequency, which is 60, and that is equal to 45. And so if we look on our graph, we find 45 is there, and if we go down, that equates to 6.2 kilograms. And we just have to do the same thing for our lower quartile. So our lower quartile is 1/4 multiplied by 60. That's equal to 15. And so we'll go to 15, go down, and that's roughly 2.4 kilograms. Now we just need to minus them from each other. 6.2 minus 2.4 is equal to 3.8. So our estimate is 3.8 kilograms. Part D says, use your graph to find an estimate for the number of these parcels with a weight greater than 7.4 kilograms. So if we look at our graph, 7.4 is here. So we're going to draw our line up. And then across. And that is roughly 53. And so everything above 53 cumulative frequency is, we can say, 7.4 kilograms or greater. So 60 minus the 53 gives us 7. Question 12a says, f is inversely proportional to d squared. F equals 3.5 when d equals 8. Find an equation for f in terms of d. So f is inversely proportional, so 1 over d squared. Now to equate these two together, we need to use our proportionality constant k. So f is equal to k over d squared. Now it says that when f equals 3.5, d equals 8. So 3.5 is equal to k over 8 squared. 3.5 is equal to k over 64. And if we make k the subject, that's 64 multiplied by 3.5. Put that into our calculator. That gives us k as 224. And so if we rewrite our equation, that's f is equal to 224 over d squared. Part B says, find the positive value of d when f equals 10. Give your answer correct to 3 significant figures. Well, we've just worked out our equation. That's f is equal to 224 over d squared. We know that in this particular question, f is equal to 10 over d squared. We'll rearrange this equation to get d squared as a subject. That's d squared is equal to 224 over 10. D squared is equal to 22.4. If we square root both sides, we get d is equal to the square root of 22.4. And d is equal to plus or minus 4.73. Now the question has asked us to give us the positive value, and therefore d is equal to 0.73. Question 13 says, on the grid, shade the region R that satisfies all the following inequalities. Label the region R. So the first inequality is x is less than 2, or equal to 2. So we're going to draw the line x is equal to 2, and it's going to be everything less than that. So everything to the left of it. The next one is y is greater than or equal to -3, and so y equals -3 is here. And it's everything greater than that, so everything above that line. The next one says y is equal to or less than 2x plus 1. And so we're going to do some quick calculations here. We're going to say y is equal to 2x plus 1. If y equals 0, what does x equal? Well, we take the 1 to the other side. That becomes 2x is equal to -1. And therefore x is equal to -1/2. So x equals -1/2 when y equals 2. And if we do the same thing when x equals 0, we have y is equal to 2x plus 1. Y is equal to 2 multiplied by 0 plus 1. Y is equal to just 1. So when x equals 0, y equals there. And if we draw a straight line, it looks something like this. And it's all values that are less than that, so it will be everything below that line. Y is equal to 2x plus 1. Let's do the same thing for this 3x plus 2y here. 3x plus 2y is equal to 6. Let x equal 0. That's 3 times 0 plus 2y is equal to 6. And therefore 2y is equal to 6. Y is equal to 3. So when x equals 0, y equals 3. And then letting y equal 0, we have 3x plus 2y is equal to 6. 3x plus the 2 multiplied by 0 is equal to 6. 3x is equal to 6, and x is equal to 2. So when y equals 0, x equals 2. So we have a line there. And so the line will look something like this. That's the line 3x plus 2y is equal to 6. And as it's less than that, it will be everything on this side. So we can see that we've created the region R, which is going to be this region here. And we can label that R. Question 14 says, the graph shows the velocity of a car in meters per second, t seconds after it starts to slow down. Calculate an estimate for the acceleration of the car when t equals 5. You must show all your working. Well, t equals 5 is here. Now, to work out the acceleration, or the deceleration in this case, we just need to draw the gradient to the tangent of the curve. So if I draw the gradient at point t equals 5, it will look something roughly like this. We know that the formula for the gradient m is the change in y, y2 minus y1, over the change in x, which is x2 minus x1. So we need to pick 2 points on our graph. I'll pick this point here, which is 3.210, and I'll pick this point here, which is roughly 6.2 and 2.5. We'll call this x1, y1, and x2 and y2. So if I plug it into my equation, I get 2.5 minus 10 over 6.2 minus 3.2. That gives me minus 7.5 on the top and 3 at the bottom. And if I plug that into my calculator, I'll get minus 2.5. So my acceleration is minus 2.5 meters per second squared. Part B says, work out an estimate for the distance the car travels in the first 6 seconds after it starts to slow down. Use 3 strips of equal width. So if we look at our graph and we use 3 equal strips between 0 and 6 seconds, we'll go at 2, 4, and 6. It's fair to assume that these shapes are trapeziums, and so the formula for the area of a trapezium is just half AB multiplied by the height. The vertical lines are A and B, and the horizontal line is going to be H. So we need to work out the area here, we'll call this area 1, the area here, which is area 2, and the area here, which is area 3. This is going to be our first height, our second height, and our third height. So if we work out area 1, it's half multiplied by H, which is 2, multiplied by A plus B, which are just the sides of the length, which is 25 plus 16. If you plug that into our calculator, that becomes 41. We'll do the same thing for area 2. We have half multiplied by H. Now H is the same for all of them, which is 2 times 2 multiplied by A plus B. Now A is going to be 16 and B is 9. If you plug that into our calculator, we get 25. And finally, area 3 is again half multiplied by H, which is 2 multiplied by A in this case is 9 and B is 4. If you plug that into our calculator, we get 13. And so to work out the total distance that the car travels in the first 6 seconds, we've just got to add up all these values. 41, add 25, add 13, and that should be 79. Question 15 says, given that A is a prime number, rationalize the denominator 1 over root A plus 1. Give your answer in its simplest form. So whenever we're rationalizing denominators, we need to multiply the top and bottom by the opposite of the denominator. So in our case, our denominator is root A plus 1. So we're going to multiply the top and bottom by root A minus 1. So 1 times root A minus 1 is just root A minus 1. And the denominator becomes root A plus 1 multiplied by root A minus 1. This looks very similar to the difference of two squares. So a little reminder, difference of two squares says A squared minus B squared is equal to A plus B multiplied by A minus B. Very similar. And so we can rewrite the denominator to look like this. It'll be root A squared minus 1 all squared. That equals root A minus 1 over root A multiplied by root A is just A, and minus 1 squared is just 1. And that is our answer in its simplest form. Root A minus 1 over A minus 1. Question 16 says, solve 4x minus 3 multiplied by x plus 5 for all values less than 0. So this is a quadratic inequality. We know that either this is equal to 0 or this is equal to 0. So if we assume that 4x minus 3 is equal to 0, we rearrange the equation to make x the subject, and x is equal to 3 over 4. If we do the same thing here, x plus 5 is equal to 0, and so x is equal to negative 5. So let's draw our graph. We know it's a quadratic graph, and we have the values of x. So x is 3 over 4, and x is negative 5, and these are the limits. And so our graph will look something like this. The question is asking us for values less than 0. So clearly for the graph, it will be all values below the x-axis. And so we know that our x value has to be greater than minus 5, but less than 3 over 4. Question 17 says, L, M, and P are three similar solid cylinders made from the same material. L has a mass of 64 grams, M has a mass of 125 grams, M has a total surface area of 144 centimeters squared, and P has a total surface area of 16 centimeters squared. Work out the ratio of the height of cylinder L to the height of cylinder M to the height of cylinder P. A key part of this question is that the cylinders are made from the same material. And as they're made from the same material, we say that they have the same density. The formula for density is D is equal to the mass over the volume. And so we can work out the density for L and M because we have the mass. And so the density of L is equal to 64 grams, which is the mass, over its volume. We'll call it the volume of L. And the density of M is equal to the mass, 125 grams, over the volume of M. Now, as they have the same density, dL and dm are equal to each other. And therefore, we can equate these two equations. We have 64 grams over VL is equal to the 125 grams over the volume of M. And so we can rearrange this equation to get the V's on one side and the numbers on the other, and that becomes 64 over 125 is equal to VL over the volume of M. Now, using our knowledge of similar shapes, we know that the ratio of the volume for any sort of shape, in our case VL over VM, is just the length or the height, in our case, cubed. So the height of L over the height of M, all cubed. And so we can say that 64 over 125 is just the height of L over the height of M, all cubed. So if we cube root both sides, we get cube root both sides, we'll get 4 over 5 for the heights of HL and HM. Now all we need to do is work out the ratio for the height of cylinder P. To do that, we're going to look at the areas of M and P. So using a similar concept, we know that the surface area of M over the surface area of P is going to be just the height of M over the height of P, but this time squared, as area is base times height. And so M has a total surface area of 144, P has a total surface area of 16, and we say that the height of M to the ratio of the height of P is all squared. Now, If we square root both sides, we get 12 over 4. So now we're going to write out these ratios and then try to combine them. So looking at this ratio here, we know that the height L to height M is 4 to 5. And looking at these two, we have the height M to height P is 12 to 4. Now this can be simplified to 3 to 1 if we divide both sides by 4. So now we need to get the values of HM the same so that we can combine this. So we're going to multiply these two by 3 and multiply these two by 5. And so that will give us HL to HM to HP as 12 to 15 to 5. That is our answer. Question 18 says there are only 4 red counters, 3 yellow counters and 1 green counter in a bag. Tony takes at random 3 counters from the bag. Work out the probability that there are now more yellow counters than red counters in the bag. You must show all your working. So there's a few scenarios in which this can happen. The first scenario is that all 3 counters he takes out are red. And so we know that there are 4 red counters to begin with. And there's a total of 4 plus 3 plus 1 counters, which is 8. So it's 4 over 8. Then he takes another counter out and it's also red. Now we've lost 1 red already, so it's 3. And the total number has also gone down by 1, so it's 7. And then the third is also red, so that's 2 over 6. If we put that into our calculator, we get 2 over 28. The next scenario is the first 2 counters are red and the third counter is green. And so again, that's 4 over 8 multiplied by 3 over 7. And then 1 green counter, so that's 1, and the remaining is 6, so it's 1 over 6. And that is equal to 1 over 28. The next scenario is that the first is the red counter, the second is the green, and the third is the red. And so that's 4 over 8 multiplied by 1 over 7 multiplied by 3 over 6. And again, we can see it's the same numbers, and so it's 1 over 28. And finally, we can say that the first counter he takes out is green, then the last 2 are red, and so that's 1 over 8 multiplied by 4 over 7 multiplied by 3 over 6. And that is also equal to 1 over 28. And so we need to add all of these probabilities together. So 2 over 28 plus 1 over 28 plus 1 over 28 plus 1 over 28 gives us 5 over 28. So the probability that after taking 3 counters out at random, that there are more yellow counters than red is 5 over 28. Question 19 says, the diagram shows quadrilateral OACB. M is the midpoint of OA, N is the point on BC such that BN to NC is 4 to 5. OA is represented as A, OB is represented as B, and AC is represented as KB, where K is a positive integer. Express M to N in terms of K, A, and B. Give your answer in its simplest form. So when dealing with vectors, it's really important that we make sure we get the directions the right way. So OA is represented as A, and so this is A. And we know that M is the midpoint of OA, and so we can say this is A over 2. OB is B, so from O to B is B, and from A to C is KB. So we can use these vectors to work out the distance of B to C. So BC will be equal to BO, so we're going backwards, plus OA plus AC. Now, O to B is B, so from B to O is negative B. OA we know is A, and AC is KB. It says in the question that the ratio of B to N and N to C is 4 to 5. So with all ratios, we work out the total. That's 4 plus 5 is equal to 9. And so B to N, this vector here, is going to be 4 over 9. And so this vector here is 5 over 9. And so we can say that the vector B to N is just 4 over 9 multiplied by the vector B to C. Now we've worked out B to C here, and so we can say that B to N is 4 over 9 multiplied by minus B plus A plus KB. Now the question is asking us to work out the vector M to N. So M to N, this is what we're trying to work out. And so in order to work that vector out, we're going to start at M and we're going to go down to the right and then up. And so if we write that, we can say that the vector M to N is just M to O plus O to B plus B to N. Now, M to O is the opposite of A over 2, so it's going to be negative A over 2. O to B is just B, and then B to N is what we've just worked out, which is 4 over 9 minus B plus A plus KB. And so we can put all of this under the same denominator. The common factor will be 18, and so that becomes minus 9A plus 18B, and then we need to double everything here, and so that becomes minus 8B plus 8A plus 8KB. Now if we collect the like terms, we'll do that here. So minus 9A plus 8A gives us minus 1A. 18B minus 8B gives us 10B. And then the plus 8KB all over 18. And that is our answer. Part B says, is MN parallel to OB? Give a reason for your answer. Well, in order for both of them to be parallel to each other, they need to be multiples of each other. We've just worked out MN, and we can see that MN contains A. OB from the question is just B and doesn't contain an A. And so the answer is no, as OB doesn't contain vector A. Question 20 says the curve C has equation y equals 2x squared minus 12x plus 7. Find the coordinates of the turning point on C. To work out the turning point, we need to complete the square. So let's remind ourselves, if we have a general quadratic formula of x squared plus bx plus c, then when we complete the square, it takes the form x plus b over 2 all squared minus b over 2 all squared plus c. So first we need to get this curve equation in the form x squared plus bx plus c, and so we're going to factor out the 2. So we're going to say y is equal to 2x squared minus 6x plus 7 over 2. Now we can complete the square for the quadratic inside the bracket, and so that becomes 2x minus b over 2. Now b is 6, so 6 over 2 all squared minus b over 2, 6 over 2 all squared plus 7 over 2. So we can clean that up. That becomes 2x minus 3 all squared minus 6 over 2 is 3, squared is 9, plus 7 over 2. And further simplifying this, it becomes 2x minus 3 all squared minus 11 over 2. We can now multiply everything by 2. So that becomes 2x minus 3 all squared minus 11. Now, to work out the turning point, we take this value here and multiply it by minus 1 and this value here. So that's going to be our x coordinate, and this is going to be our y coordinate. So the turning point coordinate has 3 minus 11. Question 21 says the graph of y equals g of x is shown on the grid. On the grid, draw the graph y is equal to g negative x plus 2. So the first thing that we're going to tackle is the negative x. As the minus is inside the bracket, that means that we're going to have a reflection on the y-axis. And so this point here, which is 3, 1, will become minus 3 and 1. And this point here, which is negative 1, 1, will become positive 1 and 1. And the final one, this point here is 1 minus 2, and that will become negative 1, negative 2. And so if we draw this, we have our new coordinates of minus 3, 1, 1, 1, and minus 1, minus 2. And if we join these up, we should have something that looks like this. So that's the first translation. The next part of the translation says plus 2 on the outside, and that means we are going to shift the graph up along the y-axis by 2. If we label this as a negative x, and so now all you need to do is shift it up by 2. So our new points will be here, here, and here. And so all we need to do now is just join these up as best as possible. And our new graph is that. And we can label this as g of negative x plus 2. Question 22 is about circle theorems, and more specifically, proofs of circle theorems. They tend to give big marks, so it's really important that we understand all of our circle theorems and are able to prove them. So it says A and B are points on a circle center O. MAP and NBP are tangents to the circle. Prove that AP is equal to BP. So it's asking us to prove that AP is equal to BP. So the first thing that we know is the line between the center of the circle to the edge of the circle that touches the tangent is the radius. And we know that the angle between the radius and the tangent is always 90 degrees. So OA is equal to OB, which is equal to the radius, and we've labeled the 90 degrees. The next thing that we know is that the length OP is common between both triangles. And so we can say OP is common. So this and this is the same. The proof is for AP and BP to be the same. And we know that OP is common for both. And so we can say that both triangles are congruent. So OAP and OBP are both congruent. And so as the same side and same angle, so we have the same side, angle, and side. Therefore, AP is equal to BP. And that brings us to the end of the paper. I hope that helped, and I hope that you were able to follow through and understand how we tackled each and every question to make sure that we got every single mark to get 100% and that grade 9. Make sure to leave a comment below to let me know if this helped you or if you have any questions, and make sure to like, share, and subscribe and hit that notification bell.